Can you guys hear me at the back?
Yes.
Yeah? Okay. So, I was in Singapore last weekend for Devfest Singapore, and there I got to know that Indonesia actually has the biggest market for mobile application developers. Is that so? Awesome. So, how many of you are Flutter developers? Just a big raise of hand. Yes. Okay. Good to see. And what about the others? What takes time? Just shout out. Don't be shy.
React.
Native Android? Yeah. Sorry, what?
React.
Swift. Okay. So what are you doing now? We're not having Apple sponsored events here. No? Okay. Yeah. All right. Good to know. Good to know. Okay. So this session is specifically about how you can enhance memory consumption of your application. And before we get started, I will just start off with a story. Just by the way, do you guys recognize this cartoon? Which one? What is it? Yeah? Adventure Time. Yeah. But it's story time right now. Okay. So a month ago, we were working on this application. It was production ready. It was deployed on the Play Store and App Store. And obviously, we had done extensive testing, right? But then we get this feedback from the client that it keeps crashing on his side. Now, obviously, if somebody tells me that it's not working rightly, or if the application is crashing, I lose my crap, right? So I go test it out. We did all the extensive testing on our side at our office, but it was working. So I was really confused, like, what's going on? Why isn't it crashing in my end? So the situation was something like this, right? So what do we say? Do we tell them that, but it's working on my side? Is it your phone that's broken? What's going on? Right? So after that, long story short, we were able to diagnose the issue, we were able to fix the issue, and everyone was happy. But this is what this talk is about, so I'm not going to tell you how we diagnose this issue right now. It's what you will learn as part of this session. So, before we get started, hello, my name is Sakina Abbas. I am the co-founder and CEO of Reactory, which is a software house that I run back in Pakistan. I am also the only Google developer expert for Flutter and Dart in my country, which is Pakistan. Yes. Thank you. And alongside that, I am very active in the communities and part of different Google-led programs such as Google for Startups, Road to GDE, Women Tech Makers by Singapore, Google Chapter, etc., etc. And I think that's my LinkedIn or Twitter. I'm not sure. You'd have to scan it to find out what that is. So yes, initially I started off with native Android, right, like some of you. And then I transitioned towards Flutter, which is what I'm doing right now. So in this session, what will you learn? You will learn some of the red flags for memory overuse. So like when you're doing development, what are the red flags that you should look out for? Then you will see what is garbage collection and what exactly is memory leaks. You will also see what DevTools has to offer, and specifically we'll be looking at the memory view in it. And finally, we'll be going through some code practices which will help you make better use of your application's memory. So, first things first, red flags. If you're running your application and you're seeing some garbage collection logs, something like this. I'm not sure if that's visible, but it says something like background concurrent copying GC free 2500 KB allocated space objects blah 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 LOS objects blah 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 and so on and so forth. Right? So if you see something like this is basically a garbage collector log. But if you see a lot of these statements, then that's bad, right? Because inherently you might think that, hey, this is actually good, garbage collection is good, it's collecting my memory that I don't need. But if you keep seeing these many times, then it means something is going wrong, because that's not so frequent as to how many times it should happen, right? Next thing that you might see, sometimes your application crashes and you would see a stack trace of something like this. It would show you some code and it will say something like exe resource type memory. Just by the way, do you guys recognize what code is this or what is this that's written in the terminal? Anyone?
WebAssembly.
Rough guess. Wild guess. Any wild guess? Come on. No wrong answers. Yeah?
WebAssembly. WebAssembly.
Assembly. That's assembly language. Okay, that's like the lowest level. Okay? So yeah, assembly language, why? Because memory at the deep down, it is dealing with like all your memory stuff, it's dealing with assembly language, right? At the heart of it. Anyway, so what do these two things mean? These mean that your application or your project is causing significant memory leaks, number one, and number two, there's an overuse of memory within your application. So, such as you're using very heavy assets, let's say you're using very heavy images or very heavy videos or stuff like that, right? Now, again, the normal question would be that if something like this is happening, wouldn't the garbage collector again collect it? And my answer to you is, it will collect it. And it will collect it, good, right? Yeah, it will collect it. So now let's look at why it will not collect it, right? Let's understand what garbage collection is. Okay, now I'm not just here to give you guys a session. I'm here to have an interactive discussion with you. So any one of you, do you have any randomest idea like what garbage collector is? Anyone? Anyone? Yeah.
Maybe collecting the memory that is not being used.
Yes, that's good. So basically, let's look at the structure of what usually happens when you're working on any application, right? So you have used objects, you have unused objects. Let's say you're working on Grab, right? And you're ordering food. So you're maintaining your cart, right? Now, let's say you've added your items to cart. So there's an instance of cart alive and active throughout your application, right? And it's maintaining this list of items. Now, let's say you go ahead, you make your payment, you place your order, and at that point your cart is gone, right? Like it doesn't have any items. It's not like it's gone. It just doesn't have any items, right? So that means you got rid of the items. Now, what usually happens is that, so the green part, it represents the objects that are being used, that are actively being used, and the red ones refer to the objects that are not used. So like, let's say the list of items that you're no longer using, that you just got rid of, right? Now, what happens is when you create a list of, or when you create any object, what really happens is you created an object and it allocates some space in a heap, which is the dynamic memory allocation part of the system, right? And then what happens that when you remove some object, when you no longer need it, then inherently if it's removed correctly, then it would no longer exist on the heap as well. In simpler terms, what that means is for Flutter developers, when you're working on forms, right? So typically you would override a method called dispose, and when you are disposing of the screen, let's say you've pressed back, right? You've closed the screen, and the text editing controllers that you were using in that form, you have disposed of them as well. What that means is that not only does that object exist anymore, but it's no longer being referenced as well, right? Now, what happens is that when you are no longer using any object, but you haven't dereferenced it, it means that it's still alive in your heap. That's what causes a memory leak. Because the memory for that, it's still alive. It's still there somewhere in your heap, in your stack, right? But it's just the object that doesn't exist. So that's basically a memory leak. And garbage collection is something that only happens that when an unused object is no longer being referenced, that's where garbage collector jumps in. If there's an object that is not being used but it's still being referenced, garbage collector will not even touch that, and that's what causes memory leaks. why the garbage collection won't intervene like we saw in the meme previously, right? So now what can you do, right? In your application, have you guys heard of DevTools, Flutter developers? DevTools, anyone? Raise your hands, people who know what DevTools is. Big raise of hands. Don't. Come on. Okay. Alright, cool. So now imagine that you are an engineer on the Grab application and you have built this entire application. And now the application is crashing somewhere and you need to figure out what's causing it. You've identified, you've looked for the red flags. You saw that there were a bunch of log statements in the terminal which indicated that the reason it's crashing is because of memory leaks, right? So you've identified this much, but you just don't know where it's happening because it doesn't give you a complete stack trace like you usually get in exceptions, right? Like in exceptions, it usually leads to a line of code that, hey, this is where this is happening, so you know where to look at. But in here, you don't know. It just gives you like, hey, something went wrong. You need to check out what went wrong, right? So this is where DevTools comes in. DevTools is, for those of you who don't know, DevTools is a suite of tools that comes with the Flutter SDK. And you can actually look at that to identify your application's performance, to look into your network requests, to look into the application's memory, the application size, and a lot of other features, right? Feel free to look at it in your spare time, like after the session, like when you go home. Right now, we're just going to focus on the memory view side of things. Now, in Flutter 3, recently, they introduced some changes to the memory view in the DevTools, right? So they're called Profile, Trace, and Diff. Profile allows you to look at the current memory consumption, like as you're using the application. It gives you this live preview of what the memory consumption looks like in your application. Trace allows you to look for specific code paths. So, like for instance, what specific class or what specific file in my application is consuming how much memory. And then diff allows you to take snapshots at different timestamps, and then you can compare the memory between the two. So, like let's say you open a WhatsApp chat screen for the very first time. So obviously it will take some time to load, right? But let's say you go back and you open it up a second time, it wouldn't take too long to load, right? So you can identify what's happening with the memory, with the diff tab, where you can actually take snapshots and compare, right? So this is what the memory view looks like. At the top you have the timeline. And you can see some legends in the top right corner, and you can see a bunch of lines on your timeline. And then in the middle part, you can look at some classes, and you can actually see that, hey, this class is occupying this much memory, and so on and so forth. And then at the very bottom, you can see something called the console. And the good thing about this console is that it will only print memory-specific logs. So not all logs, just memory-specific logs. So, over here, what's important is that I would like to walk you through what these legends mean, so that when you're using DevTools memory view to identify the memory issues in your application, you just know how to use it. Okay, you're not just shooting for a blind spot, right? So, let's take a closer look. This is what it looks like if you were using an application, and this is how the memory view looks like in the timeline view. So the red line, in fact, I think okay. So these are the legends that you need to look out for. Now there are a lot of legends that are being used, a lot of lines, a lot of colors, a lot of shapes and sizes, right? But for you, what's important to know is that the blue part, this light blue part, like right over here, right? This part is the part which is directly related to your code. This is the memory that your Dart objects are utilizing. And then we have some others as well. So like this orange dash line at the top, that is basically the memory that is available to be used. It's the in and out memory memory. So like, it's basically the space or the memory that's available for your application to run on your system. And then the dotted line below it, which is like right above the blue region, that is the memory that is actually being consumed. And then the breakdown of that is the thicker portion, which you see like the light blue section. That is the amount of memory that your Dart objects are using. So the next time if you have identified that my application is crashing or running slow due to memory overuse, then this is something that you need to look out for. And as you're running the application, just watch out for it. Is it growing? Is it shrinking? What's the pattern, right? Okay. Then the next part that we have is, I think that's diff, yeah. So in diff, if you can notice, there are two snapshots that are taken, and if you can notice, it's actually showing you different classes on the left, and it's showing you how much new memory it has allocated and how much it has released, what the difference is, has the difference grown, has the difference shrunk, what's the difference, and you can actually compare them. Now, I understand that this can get quite overwhelming and quite complicated because these are classes that you don't normally recognize, like what is picture image, what is opto image, right? Cache network image, okay, it's something that you might still recognize, but what are these other classes, right? And then also, the good thing about DevTools is you can actually set a filter for which classes should be shown here. If you only want to look at classes which are specific to you, like the classes that you created, and you just want to see how much memory they're occupying. So like for instance, how much memory my cart class is occupying, how much memory my order tracking class is occupying, and so on and so forth, right? So with that you can actually specify that, hey, only show me the classes that are created by me and don't show me anything else. The other good thing which is present over here is that at the very bottom you can see that there is this code path. So like in this case, you can see that it says stateful element, list, multi-child render object element, and so on and so forth. So this is something where you can actually go to that specific line of code where you might want to expect the memories in your application. Alright, now that we have looked through the red flags and we have also seen that you can diagnose memory-related issues or identify them using DevTools memory view within your application, let's look at some code practices that you might want to consider the next time that you're building an application. So let's look at the do's first. First of all, the way that we'll structure is this, that first we will look at the very basic practices, and then we will look at some more advanced practices that you probably haven't heard of as yet. So the basic ones is this, that always dispose of your controllers in the dispose method, whether it's text editing controllers, whether it's animation controllers, what other controllers that you're using, make sure that you dispose of them in your dispose method so that they're properly dereferenced. Number two is, if you're using any streams, you have any active listeners, make sure that you again cancel their subscription in the dispose method. Now, we all love to use images, right? Our designers love making use of images in applications, and we use them too because, hey, it makes the application look good, right? So if you're using image.network, image.asset, whatever kind of image that you're using, make sure that you give it a cache height and a cache width. How that works is usually when you create an image widget, whether it's a network image, whether it's a memory image, it will always fetch it from the source directly. But if you were to specify it cache dimensions, like cache height or cache width, then it would load that image for the first time, keep that image in bytes in the cache directory so that the next time that you recall it, it's faster, right? And hey, the issue that our application was having was we were using a lot of images. It was kind of like an application like Grab, which was showing a lot of menu items. So if you were to scroll very quickly, the images were getting rendered, they were getting de-rendered, rendered, de-rendered, and this pattern was causing the application to leak memory, and make an overuse of memory because of the fast recalls of the images. And when we just added these two lines in our image widget, it resolved the issue for us then and there. Okay, so if your application is using a tab bar view, right, or if it's using a page view or something like that, you must have noticed that if you switch to a different page or a different tab, you must have noticed that when you go back to the original page, the state has been lost. It's starting right from the beginning, right? So all the items in your list view or your grid view, they're getting rendered from scratch again, and you don't want to do that. So instead, just use automatic keep alive. What it does is that it persists the state within your iterable widget, which is a list view or a grid view. So again, that really helps with the memory because things are not getting initialized and rendered from scratch. And then there's this thing called read reference. It used to be there before. I'm not sure if it's deprecated right now or discontinued, but it's still there. And if it's not there by its original name right now, I think there are workarounds for packages which does that. Anyway, what read reference does is that let's say that you have disposed of your controllers, you have canceled the subscriptions to your streams, you've done everything that we've discussed so far, right? But let's say there's still a possibility that somewhere in your application there's this sneaky code snippet that is still getting memory leaked, right? So what do? You just declare it as a read reference. When you declare an object as a read reference, it basically tags it as a read reference, which indicates to the garbage collector that, hey, if this object is no longer being used but it's still being referenced, that's what read reference basically means. You can actually approach me and you can basically get rid of me. That is what read reference does. But there's a con to that because an overuse of that might actually cause your application to malfunction. Like let's say there was a use case where you stopped using an object and it was also collected by the GC, but then let's say there was a use case that you kind of needed it somewhere in the background or something like that, maybe like providers, right? So in that case, it would actually cause your application to malfunction. So use read reference, but with caution. And then finally, use finalizers for memory cleanup. Now, the dispose method, that is for when your screen is getting disposed or when your widget is getting disposed. Basically, when your UI or part of UI is getting disposed. What if you want to do some cleanup when your API is done being called, when some function is done completed, and you want to get rid of something at the logical level, at the data level, right? This is where you would use finalizers. It works pretty much how disposing works. So once let's say you wanted to run a timer just once, and once it has completed, you want to clean off some of your variables, you want to clean off some of your objects. This is where finalizers will come in handy. Now, what you shouldn't do. One of the things that I really common with developers is that they create widgets and then they store them in variables. Please don't do that. Please just don't. Because when you create a widget and store it in a variable, then that means Flutter is no longer responsible for handling its state. It's no longer responsible for disposing it off when it's getting disposed. It means all the responsibility lies in your court. And if you're already going into memory leaks and overuse of memory, then what's to say that you will take the necessary steps to handle this, right? So instead, never store your widgets in a variable. Don't overuse global keys because global keys, the concept or the scope is that they will remain alive as long as your application is alive, right? So use global keys where necessary, maybe for navigation, maybe for your overall application's lifecycle or state. Just don't overuse it a lot, okay? And finally, avoid deep nesting of widget trees. If there are widgets that you can localize, like other speakers talked about, try doing that. The benefit of that is you will isolate their behavior and you'll shift the responsibility from yourself towards Flutter. So let's say screen, and a small part of that, I shifted that in a separate, let's say, in a separate widget. Then when it is getting disposed, or when I'm interacting with it, or whenever I'm updating its state, then most of the responsibility will already be catered to by Flutter itself, and you wouldn't have to do much. So it's just better because then it's not reflecting on your entire trajectory. With that being said, that we're pretty much done. So if you have any questions, I'm here. You can ask me, you can stop me anywhere. And I think that's my Twitter or LinkedIn. Again, I don't remember. You'll have to scan it to make sure. And thank you for having me. I hope you learned something valuable from this. And yeah, see you around. Thank you.